We're going to start this unit, this section rather, with a little algebra review about proportions. So here's a very classic error that kids make a lot. We have John and Jenna have each worked a problem, and one of them has made a mistake and one of them has done it correctly. So go ahead and pause the video right now, see if you can identify where they made the mistake and what would prevent you from making this mistake. I hope that you see that the difference happens right here. The algebraic piece that kids often forget is that a fraction bar implies parentheses. These two get locked together, and you need to get in the habit of doing that before you cross multiply. So in this case, John is correct. You can see dramatically different answers, and so that small error can make a big difference. So when we go to do these problems, the very first thing I want you to get in the habit of doing is just putting those parentheses in before you cross multiply. 6 times 4x minus 5 is equal to 3 times negative 26. At this point, if you want to divide both sides by 6, that's fine. Most of you will prefer to distribute. So I have 24x minus 30 is equal to negative 78. I'm going to add 30 to both sides. Remember always that process of undoing. 24x is equal to negative 48. Divide by 24, and x is negative 2. It's a very straightforward cross multiplication problem with some basic algebra. Now C, there's a quick typo in your notes. The second fraction should be x plus 2 over 1. When I go ahead to do my cross multiplication, get your parentheses in. And so I have 4 times x plus 2 equals 2 times 1. So I have 4x plus 8 equals 2. And so I have 4x oops, 2x. I forgot my x here. 4x, I'll back up. I have 8 is equal to negative 2x. If I subtract 4x from both sides, because I forgot to write my x right there, subtract 4x from both sides. Now I'm going to divide by negative 2. Remember, I always want to get x alone, even if it means I have to divide back to the left. X is negative 4. So what does this have to do with similar figures and the transformations we've been doing? So in order for two figures to be similar, now we're talking similarity, not congruency. Both of these have to be the same. All angles must be the same. They must be equal. No matter how much I blow up or shrink a figure, the angles do not change. The sides, however, all sides must be proportional. I have to blow them, and that's all corresponding sides are matching up. I must blow it up or shrink it by the exact same amount. So if I look at in A, are these quadrilaterals similar? My quickest test is my angles. And these are not similar because the angles are not equal. That is the quickest way to tell because the angles must be the same. If they're not, it is not similar. If I look at example B, all the angles are 90. So my angles are equal. So check 1. Now I have to check proportionality. Now corresponding sides to corresponding sides. So is 3 over 3 at the same proportion as 5 over 3? And I think all of you are pretty comfortable in saying that those proportions are not the same, therefore it is not similar. I did not, here I multiplied by 1 to change it. Here I divided by some other number than 1, and I'm not changing my figure proportionally. If you visually can't see it, like here, Another thing to do is you can check your cross products. And it's clear that 9 is not the same as 15. Your cross products will have to be equal. And that's a strategy we'll use in the next example. So are these solids similar? Well, I don't have any angles, and so I have to just check sides. Now, corresponding sides to corresponding sides. The height of 20 has to compare at the same rate to the height of 8 as the length of 25 compares to 5. Is that the same proportion? Okay. Now some of you are going to do the division and say 20 divided by 8 is 2 point something. 25 divided by 5 is 5, and say not similar. We can also check our cross products and say 100 is not the same as 200, therefore not similar. We did not multiply by the exact same number or divide by the exact same number to change these figures. We blew it up by different amounts. So we can reduce the fractions or we can use cross products. If I have 3 dimensions, I have to check all 3 dimensions. Now, this second box is laying on its side. So the longest side corresponds to the longest side. Is 27 over 9 at the exact same rate as the second side to the second side? 21 over 7, is that the same rate as 12 to 4? Now it's a little harder to use cross products when you have 3 things, 3 fractions. You can't do that. So let's reduce each one of these. This would reduce to 3 over 1, to 3 over 1, to 3 over 1. They have the exact same proportions, therefore these are similar figures. To change from the big figure to the little figure, I multiplied by 1/3 in every situation, or I divided by 3. So I proportionally shrunk this. The key is, though, to find the biggest side, match it with the biggest side, the second with the second, so that you are matching corresponding pieces with corresponding pieces. That is the end of section 2. Good luck with your homework.